science, video, physics, and such. I guess I'll read a couple of the comments in the last magnetism type video, and then we'll move on to Piero. Did a room, and we talked physics halfway through, so I'll leave a link below, hopefully time-coded, I suppose, to the physics conversation. It didn't really go... I mean, it's okay, you know, it's just what you get, so you have to settle for that. But I just don't think he pays enough attention to the argument being made to counter it with anything else except we say so. So that's all you get. So anyway, and the lensing thing, I've already been over that, and the fact that the lensing has to be in the lens, and the lens has to be where the gravity is, and they're not following those two simple rules, so it's a big fraud is what it is. It must be something else, so they just don't want to admit that. But anyway, what else? Yeah, and then I'm going to talk some about relativity and velocity. Got a little bit on the subject with Piero, and you know, he attempts to mitigate the conversation by saying, well, that's what Einstein was saying. And it's not what Einstein was saying. If Einstein was saying it, then I wouldn't have any disagreement and everything would be wonderful. So it's clearly not what he was saying, and it's just irritating that people say that's what he was saying when it's not what he was saying. You know, quite obviously, in the sense that there was no acknowledgement that the energy for gravity comes from the field, and that the field is made of something that has energy. Yeah. Anyway, yeah, so I'll get to that. So first, Piero's useless comment on the video. A fractal is self-similar because it looks similar at all scales. Well, anyway, fractals are kind of irrelevant to real physics because there's no such thing as a fractal in real physics. So the ones in nature, the fractals you'll find in nature might go 2 or 3 deep, and that's it. They're aberrations of convenience, or, you know, the fact that a spiral is a common function, and then the spiral's inside the spiral, and the spiral's made of spirals. But like I said, if you can find it in nature, you'll only find it going 2 or 3 levels deep, and that's it. Because it doesn't go infinitely one way and infinitely the other way. None of that happens in real physics, because size does matter. Size changes the physics. Physics at the little scale is, although it's the same physics affecting us, its expression is completely different. It just doesn't, the same, if you understood the basic rules, I guess that's the way to say it, because they don't properly define the basic rules, you'd understand that the rules are the same. But the fact is that when you pile a whole bunch of the stuff together, it has behaviors that are more complex than those simple rules. They're a more complex expression of that simplicity over time. Funny things can happen. You do enough permutations, and you're flipping a coin, the coin stands on end. Something possible but not likely becomes possible. Anyway, but that's not even. But the point is, this isn't fractals aren't physics. So just no, that's a little game you play with mathematics. It's not a game describing reality. It's just a game you can play when you break the rules of infinity. When you say I can have infinities, then you can have fractals. Otherwise, it don't happen in reality. The first mechanism has to be made out of simpler parts. There's no cars made of cars made of cars made of cars. Complex things can't poof into existence. They have to be made, and they expire at a certain weight. You make human beings a certain height, their bones will break. Those are the rules. The rules go all the way down to the rudimentary physics, but obviously you can sort of understand that the rule happens out here in the big physics. But it's the little physics that makes the rule the rule. Just can't make humans that are 100 feet tall. Bones will break. Anyway, so now the whatever guy, whatever, Anyway, magnetism is a dielectric field. Okay, that says absolutely nothing. Faraday. I.e. loss of inertia acceleration. Well, inertia and acceleration aren't the same thing. So inertia or acceleration, so you're basically saying velocity or acceleration, and you lose those things and now you're magnetic. Okay, that means nothing. That doesn't draw me a picture. Is force and motion, i.e. spectral confugal divergence, centrifugal divergence. No, doesn't do anything for me. That's simple. Wow. I'm sorry, that isn't simple. Not mystical. That's logical and rational. Well, again, I can't logically and rational make that do anything. Something confugaling, centrifugaling, doesn't exactly explain attraction and repulsion. Irrational is inventing particles, buddy. Well, again, the evidence of bits of stuff, quanta, of element, is just there. Yeah, anyway, all our fields. Well, again, fields of what? Non-elements, non-things. That doesn't, you know, where's your thing? A particle at least is a thing. A field made of nothing doesn't mean anything. And fields are not particles. Well, what are they then? Elastic bands, pink ribbons, poofy poof, poofy poof. If you don't grasp that, no, and I don't, you understand nothing of field theory a la Tesla, Faraday, Heaviside. Well, you know, yeah, that's right. I don't think that those guys got it right, obviously. I think the guy, you know, 300 years ago, whatever, the French guy, not Lesage, but the first guy, he got it right. Feynman was ahead of the cult of atomism. You should watch his BS video explaining magnetism. I did. I played it. He doesn't. He can't. He shudders. Yes, he stutters. Yeah, but he does. But he tries to explain that some things are complex, and you have to have some knowledge of some physics to understand the deeper physics. And so what he's basically trying to say is that I can give you part of the explanation as a model, and I give you part of the explanation as a mathematical model, because we can't see it, and we can't know what it is, but we do know what it does. So we can mathematically explain it, but we can't show you a picture of it doing it. We can show you what goes in and what goes out. We can't show you what's going in and what's going out. And that's not a horrible concession. Feynman mystified it, virtual particles. Well, again, I don't think he entirely mystified it, but he didn't explain it, and that's true. But he did explain it with analogy, in the sense that he said, take a rubber band, for example. You know, why does it stretch with heat and all that, you know. So the explanations do go kind of deep into why something is the way it is. They're understandable? Question mark, question mark. Well, they would be if he explained them better. If he explained them as not being virtual particles, but being actual gravitons, then you would have the right answer. But, yeah, he didn't have the right answer. They don't exist. That's the same as unicorns and fairies, i.e. mystical. Well, you're going to be proven wrong, and sorry. Yeah, you're just wrong. And I don't know whether you need to be mocked for it or something, but I mean, you're just so arrogant, and so I mean, part of me says that somebody in the future watching this video should say, hi, yeah, let's go mock that guy, because yeah, Gary sure was right, and this guy sure was wrong. That's all I can really say to it. What virtual photon particles? Gravitons. They don't exist even in by their own admission. Well, as stated, they've called them virtual because they don't know what else to do, because they know that mathematically something like this exists, but they can't figure out where it would come from because they can't understand, you know, they're physicists, and unfortunately they can't understand kinetic reactions, interactions, and that gravity is an active force, not a dead force. Now, see, if they thought of the ether as being active instead of dead, then they could mathematically make it work. But they always imagine the ether as being a medium, like a dead sea, like an ocean that has nothing happening. And it wouldn't be a medium unless it's active. And that's where they got it wrong. They didn't realize that a dead medium would need energy for things to move through it, instead of transmitting them frictionlessly it would transmit them by consuming their energy. So taking a cue from quantum magicians, we then ask the expert fool relativist, since you declare magnetism to be mediated by virtual photons, what is same? Well, again, they're the same mechanism that creates the energy you see in gravitational movement. The energy is coming from the field, and the field's made of little quanta bits that have a velocity and a direction. And that's what happens. They exchange the velocity and direction they have for the force's velocity and direction, and they obey the rules and say, okay, the force says, and that's what they do. They absorb a change in their disposition, and the change in their disposition changes what they spew, and what they spew will decide whether something's attracted or repulsed. Pressure. It's all pressure. So, taking the answer received, yes, here we have it. A virtual particle is an abstraction. Well, again, this isn't entirely the subject of my video, so you're going to just hang on everything Feynman says instead of hanging on something the other person actually says. So I only mentioned Feynman's virtual particles as a rebut to you, saying, well, look, if you make them non-virtual, how's that? And you didn't do that. You just keep pretending they're virtual. I'm saying they're not virtual. They are a fact. They do exist, which facilitates in calculations and understandings. The terms is very vague and loosely defined. They never appear in inputs and outputs of experiments. All right, gravity doesn't ever show up until it actually shows up and moves something. So you don't get to see gravity do its business. You only see the output. You only see the consequence, you don't see it do it. Their existence is questionable at best. Well, again, I would argue that gravity's been around a long time. There's nothing questionable about the effect, and it's just that they keep not establishing a cause. However, they are very useful in rendering concepts and making equations balance out. Well, that's the funny, ironic part, is they've conceded that the math works if they create energy in the force, and yet they just wouldn't take that step because they were not smart enough to know the difference between nuclear forces and rain or something like that. It's a little more complicated. Real physics is a little more complicated than day-to-day, I threw a brick at you and it dented your head. Oh, that's not exactly how real physics works. So anyway, yeah, so now we'll get to the velocity thing. I will get to this is the whole thing, and I'll just try to explain it really simply by by drawing some more pictures, right? Okay. I'm just saying, if I draw pictures, maybe that will make it. You can just get the idea of this balance thing in this field thing. All right, and because it's really not that complicated. All right, so the one thing to concede is that the stuff that's happening on the nuclear level, there's just a ton of these interactions. So they say, physicists, that our size differences, it's 1,000,000 billion, times smaller to go from us to the atom. And it would be like 1,000,000 billion pixels of definition to go from the radius of the atom's nucleus to the actual bits, the smallest thing that our energy scale will permit. So you could argue that an electron, for example, would have 1,000,000 of these quanta in it, and that something like a proton would have 1,000,000 billion, or a bigger number, billion, whatever. So you have to understand that what it does becomes kind of probabilistic. Like, the more you have of something, the more you wipe out all the variations, all nuance, and it just becomes kind of a rounded thing. It takes away all the irregularities when you have a ton of permutations. So it all becomes just some sort of probability math in terms of stuff goes in, stuff goes out. You can sort of see it as it's much more of a system. When something has a million parts, it's a system. But here's the rudimentary function. Okay, so the rudimentary function is this idea, okay, that there's a field around us, and that field has arrows going in all directions. But clearly, the only ones that are going to matter are the ones that are going to hit you. So I've tried to make this point before, but there's all this stuff going in all kinds of directions. But in every location in space, there'll be a certain amount of that stuff is always going to hit you. No matter where you go on the field, okay, you're the target of some other player. Some other player's heading right for you. And because of this huge number of these things, you're sort of getting that now, right? Million, billion in just the, one little fleck of your fingernail. There's a lot of things that are going to hit every little space in space is the target. And there's all these bits that are heading right for it. And so that's a kind of pressure. You're constantly being bombarded by waves. It's not even waves because it's so irregular, because they're just constantly coming. But yeah, it's like that in the sense it's just this constant pressure right for you. And that creates this idea of a shadowing effect, where something going this way shadows the pressure. That shadowing of the pressure means less stuff gets this way, so this thing ends up going in towards that thing because of the equal pressure out here. So the pressure is always high out here, and sometimes, in magnetism it's the reverse, but I'll explain that later. The pressure gets low in here. Alright, and that's it. It's that simple. So you can sort of understand that if there's a low pressure, the stuff is going to start condensing around the low pressure. It's going to keep getting pushed into the low pressure from the high pressure. So it creates the idea of these orbiting things. Now they don't have to technically be orbiting. And I would almost argue that once you have a million of them, maybe they're not orbiting. Maybe they're not doing any of that really. In the sense that they're really just going in straight lines. And what's really happening is they're just exchanging identity. So this one going this way gets replaced with one going this way. And then this one goes this way, and then it gets replaced with one going this way. And then this one gets replaced with one going this way. And that's what maintains the pattern, is they just keep getting replaced. And replaced is the same thing. I've been over this before too, but we'll do this one more time. That you can think of interaction two different ways. You can think of things going straight through each other, in the sense that the stuff comes in, stuff goes out. There's two things. One thing's going this way, one thing's going that way. Or you can think of it as the two things end up banging into each other and bouncing off each other and completely changing their direction. It's the same end result, but the real key is that something did change. This thing is now exchanged directional information. And this description creates the opportunity for creating the circle. You see? This creates the idea of being this. You can't create circles. Everything's just going straight and there's no capacity to make a circle. This, you create circles. So the fact is they do exchange directional information, even though they can look like they didn't do anything, and that's the sort of a mini paradox. But anyway, it's the reason why things do this, circling, is because they're actually exchanging direction. So this thing actually does turn. It's just that it's turned because there's a constant bombardment that's turning it. And it's turning it by just exchanging directional information. That is something going, again, pointing out, it's going this way, something hits it that's coming down from some other direction, and its direction is exchanged, so now it's going to go in some vector that tends to be in this direction, and then the next one will be tending to go in that direction, and then tending to go in that direction. And that tendency will always balance out because of conservation. This is conservation. There's two things going this way, 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 and that creates a balance. And as soon as I change it and make three things go this way, then I'm going to have an imbalance, and that imbalance means I had to extract one from the field. So that means the field, if I create an extra one over here, it means the field is less 1. So the field is going to want to compensate, and it's going to want to return that extra 1 over here, going the opposite way. I mean, it's just conservation rules in the end. The field starts off balanced. Matter creates a kind of imbalance when it's out of balance, but once the matter is balanced, it restores the balance. So everything's in balance until you create an imbalance, and that's when we see it, and we call it energy. So the only time we ever see energy, the universe is full of it, but the only time we see it is when there's an imbalance in the local field or the broad field. It's usually just the local field, but there's a local imbalance. But the point would be is if I have an atom now, so just think of this image of just being, identity is defined by what you possess. And so if you possess equal numbers of arrows going in 2 directions, you won't go anywhere. You'll be stationary. So you can sort of understand that if I'm in a place and I'm composed net of just as many arrows going in some vector in the upward direction as I am downward direction, then I don't go anywhere. But if I change that, if I run a force through me, okay, that hits my arrows, and now more of my arrows end up getting changed in their direction. So now instead of 3 and 3, I now have 2 and 4. So one of my that way arrows got changed to a that way arrow. Well, now my net balance is 4 and 2, and so now I'm going to start moving this way. And I'm going to start moving that way because that imbalance is going to spread technically through every single bit of me. Is going to, for some moment of time, move in that direction more than it moves in this direction. So you have to think about every nuclear bit inside of you. When you move, every single nuclear bit inside is being moved. And why does it move? It doesn't just move because it's being dragged along by some magical force. And if it was, you'd understand that would consume energy. If I tried to drag something, I would pay for it. As soon as I start to try to move it, I'd have to pay energy to do it. And why does it take no energy? Once I have velocity in space, I keep going forever. Is because it doesn't consume any energy to be imbalanced. It consumes energy when you try to change the balance. When you try to fix an imbalance or when you create an imbalance, that's when energy is revealed. So it's when you're accelerating or decelerating that you have to, energy has to show up. Something to change the balance. And so that's all we're really made out of. So it's a percentage of you. So when you're moving, it's a percentage of your little bits are in each millisecond moving extra in that direction that you're moving. So it's just like if I was to ask, if you were standing still and I asked you to dance, you were dancing as fast as you can, and then I said, well, move to the left as you're dancing. You'd understand that you'd have to make some kind of calculation that you won't be able to quite dance as fast because every now and then you're going to have to take that side step. And every bit of you is doing exactly that. It's dancing, and then every 10 seconds we could say, it takes a step to the left. It takes a step to the left. It takes a step to the left. Well, everybody's doing it every 10 seconds on a different 10-second cycle because it all goes into the field. So again, we're back to this field argument that if I'm changed, then whatever change happens to me, if I absorb an arrow from the field going that way, it means I released an arrow in force going the opposite direction. I had to give away what I took. And those mechanics will bleed through a system. The field becomes less as you become more of something. So the more you become left or right, the more the field becomes right. And so the more the field tends to want to do something else to something, somewhere. So that's the equal and opposite effect kind of argument. Alright, so getting to some of the stuff brought up by relativity. So anyway, that irritating Roboto guy, left some links, but I don't know if he deleted them, what happened to them, on Piro's video. Some images or whatnot, but yeah, I mean, there were something from Wikipedia, but they were just the images, so you couldn't tell what the native page was, so it just wasn't worth the trouble. So I just went to the relativity page, and I did find some crap here that's just kind of annoying, because these are arguments that shouldn't even be, these other consequences, these shouldn't even be on the special relativity page, in my opinion, because they don't relate. So anyway, but the real problem is, these concepts, there's the equivalence of mass and energy, so the E equals mc squared thing, and what they're trying to do is explain gravity, because they have to somehow explain how you can have this motion of gravity using the masses that you have available. Somehow you have to extract the energy out of their mass, either the Earth or the Moon, in the Earth and the Moon case, and they can't do that, so then they create this extra component of time that becomes the energy component, but it's not really time, it's the field. So that's the fraud here, is they're mislabeling the field as time, and it's not. So they've added the necessary variable, to get the energy, because they know the energy didn't come from the moon, they know the energy didn't come from the Earth, and yet the bodies are moving, and so they have to explain that, and so they explain it by giving energy to time, and that's kind of a fraud in the mathematics, in my opinion, because obviously time has forward vectors, and so they're using the forward vectors of time to really say that's energy, and it's not. So anyway, I just want to say that that's where that comes from. That's why he needed to create space-time, was that what he really needed was space energy. He needed a source of energy, and so he's using the word time because it doesn't have any meaning, okay, as a virtual energy source, instead of naming the actual energy source, which is the pressure of gravity. Alright, so that's one. I don't think I need to read this. You'll get it if you read it. That yes, it's really just a search for a component of energy that doesn't rely on the masses of the bodies actually interacting in the interaction. Okay, so then we get to this one. How far can one travel from Earth? And this was just such nonsense. And so I just wanted to go through it just to explain why it's impossible from my theory, any of this nonsense. Since one cannot travel faster than light, one might conclude that humans can never travel farther from the Earth than 40 light years if the traveler is active between the age of 20 and 60. One would easily think the traveler would never be able to reach more than a few solar systems which exist within the limit of 20 to 40 light years from Earth. But that would be a mistaken conclusion because of time dilation. So again, this idea that time gets dilated, and so obviously by my theory, time doesn't dilate. You dance slower, right? So you can understand that if you're dancing and I ask you to move left very fast, I ask you almost to run left, you're not going to be dancing very fast, right? Very few little taps of your shoes are going to be tap dancing anymore, right? That whole gig is almost going to be over if I ask you to run to the left. You're going to have very little time to do your dance because you're going to be busy running. And that's a change in your metabolism. It has nothing to do with time. You don't function the same when you have high velocity. Your matter changes. That's what changes. Time doesn't dilate. You slow down. You in a sense, it's like cryogenics. Okay, you freeze, you cool, you lose your activity as what you were, and your activity is your identity. Correct? I mean, the momentums, the movements inside of you that are holding you together are what's holding you together, and as those deteriorate, you would fall apart. But anyway, that's a kind of freezing we haven't gotten to yet. I mean, you freeze us enough, we lose our identity. But that would be a mistaken conclusion because time dilation. Hypothetical spaceship can travel thousands of light years during the pilot's 40 years If the spaceship could be built that accelerates at a constant 1g, it will after less than a year be traveling almost the speed of light as seen from Earth. Well, technically as seen from anything. So again, I'm arguing that there's nothing relative. Yes, we have relative conditions. We can both be on a bus going 60 miles an hour, and you can be running that way, and I can be running that way, so you are going 60, 70 miles an hour, and I'm going 50 miles an hour relatively. But that relativity has nothing to do with the fact that we're both going some absolute speed relative to our molecular structure, relative to the total imbalances in our orbits, so to speak. We have a gyroscope and it's wobbling in some direction that we're actually going. We have a real vector in space that has to do with the total net. If you take all the arrows that you're made out of and you take all the opposites and balance all the opposites out, whatever imbalances you have in those opposites, mostly top to bottom, left to right, cut it into 4 sections, really 2 inverses, that's going to decide your vector, which you're really going at any 1 second. But as with all these things, each piece of us is doing a different vector at any 1 second. At any one moment in time, some pieces of me are going this way, some pieces are going that way, some are they're going in all kinds of directions. Obviously, because they're all in different spirals and different circles and different arrangements, and they're all traveling different vectors. But there's a net. When you add them all up, what's the direction? And that's the direction you're going in. It's absolute. But anyway, so this whole argument, though, that less than a year be going the speed of light. So I'm just, what's the consequence of going the speed of light? So here's the simple point, that if I make something go the speed of light, that means I'm giving it more and more velocity. So I'm going to give it the absolute velocity. And the absolute velocity the implication would be that not just a few arrows are imbalanced, but every arrow ends up being changed. So not only all the arrows going left and right are up and down, but all the arrows going in any direction. So all the arrows that were going up are now converted to arrows going the direction you're moving. All the arrows going down converted to arrows going in the direction you're moving. So you no longer have any pattern. The pattern's gone. There's no circulars, there's no anything. Every bit of your quanta has basically been turned into a photon moving in the direction that you're going. So if you're matter, if you move matter the speed of light, you turn it into light. It's not matter anymore. It's just a big bunch of photons moving that way. It's a laser beam. It's a school of fish. And so again, I'll use the school of fish analogy because that's one you've all seen. You've seen them all swirling around each other, right? They're all swirling. Same amount of energy as when they're all going in one direction. Now, one thing looks energetic, one thing doesn't, but it's the same. And it's the same with this velocity. The quanta don't care which way they're going. It doesn't matter to them. It's not more work to go this way than that way. But it appears like we're doing something when we have an imbalance. But to the mechanism, it doesn't make any difference. It's just stuff going. But obviously, you can't maintain a circle or a square. You can't maintain an orbit if all your bits have to go this way. If none of them are allowed to go down, if none of them are allowed to dance anymore, you can't be dancing, right? So if I ask you to run as fast as you can to the left, you can't dance at all. And that's the same rule that applies here. You're no longer matter. So if I speed you up, what happens is your matter will turn to energy. It will not stay together. So anything getting anywhere close to the speed of light is not going to be matter anymore. It's going to be releasing energy. And I think you see that in a lot of stuff at the end of the universe. It seems like it's releasing a ton of energy, and it is because it's falling apart. It's rapidly degrading because it's losing energy. It's losing form. It's converting into, it's just revealing itself as being energy by releasing it in one direction. But there is a paradox there too, so I don't want to get into that one because there should be no light coming towards us because frankly the stuff's moving away and the energy energy should be released in the direction of its movement. But I won't get into that. Right, so I don't know if there's anything else to say here except for this premise that they're presuming, you know, even though they call this something you're imagining, the fact that you can, hypothetically, as they put it, that there's some possibility that you can take solid matter, move at the speed of light, and it won't degrade the matter into non-matter. And it will. It will not be matter anymore. And it will not be matter for the reason I'm pointing out, is that every little bit would now have to be moving the speed of light, because there's no time left over for dancing. There's no time left over to be matter anymore. Time dilation will increase the lifespan as seen from the reference system of Earth. Well, again, it doesn't matter where you're seeing it from. Okay, this cryogenic effect, this slowing down thing, is an absolute slowing down. It's not just slowing down from the frame of Earth. It's slowing down from any frame in space. Even somebody going faster than you would see you going slower, would see you slow down. So whatever you're, you know, you're just obviously doing that. You're converting into energy. You're gaining velocity in a direction, and that's viewable from every frame of reference. There's no frame of reference where it wouldn't look like when you're accelerating or when you're decelerating that you're accelerating or decelerating. That's never relative. That's always absolute. And velocity technically is the same thing. Your velocity is always something in a direction. Your net velocity. You have an absolute velocity. There's a certain number of your quanta that have a certain imbalance in some direction, and that imbalance is a fact. And the more imbalanced you are, the faster you're going to go in that direction of the imbalance. Right. Alright, so the only other important rule is this, again, the conservation thing. So just to understand that the system is conservative in that the exchanges you make with the field, it's like the matter itself. So matter itself can be argued that these are arrows that end up closer together to each other, the ones that end up in these relationships. That's what matter is a condensation of matter. So it's like little bits are being, the BBs are being pushed a little bit closer together, and so you can fit more of them in a bit of space. But it means that when they condense into matter, it means the field itself gets weaker, because the field, they separate further because there's less BBs in the field. So the more BBs you put into matter, the weaker the field gets, technically. And so that's a really important conservation idea. But it's also true, again, of velocity. If I absorb a bunch of arrows going in one direction, if I run left, there's a bunch of arrows somewhere going right in the field. The field now has an imbalance of arrows going right, because I've changed my arrows to all lefties. And so I have an imbalance, and the reciprocal to my imbalance is in the field. And the field will probabilistically pay that back. And we see it in these big objects in terms of their movement. Yeah, so that's enough. I don't think I'll bother with the magnetism thing again. I've already been over that. It's the polarization issue, and that just creates a magnification and a negation of gravity. So magnetism basically negates half the gravity in the North Pole circumstance and doubles it in the South Pole circumstance, and vice versa, kind of a thing. So it's just changing sensitivity to a form, and so form matters. This way in one circumstance will be double gravity, this way in another circumstance will be no gravity, and that's all. And that creates the opportunity for repulsion, in the sense that you can create a field between two things that are full of polarizations that don't affect you and don't affect him. And if neither one of us are affected, the thing will be drawn towards us. And then if I produce the things, all of them that are affected by you, and they're not mixed by any that don't affect you, then I've doubled the strength of the gravity, essentially, by creating all one polarization. And that would create repulsion, in the sense that the field would have now twice as many of the one kind that I'm sensitive to. Alright, I think I've said that well enough. But that's the thing to understand, is that gravity is coming at you from all directions. Right now, there's gravity. And if I'm not accelerating, if I'm not absorbing any of the gravity, right? So there's a bunch of gravity coming from this side. If I don't absorb it, then I don't create a lower pressure on this side of me. So the gravity essentially just goes right through me. It's only when I grab some of the arrows that I create a deficit for the other thing, and the other thing will end up getting pushed, in a sense. And it's only when he absorbs it, when he actually moves, that I end up feeling the gravity he created. So gravity has to be induced, like magnetism. But it's all around us all the time. All the time it's going through you. And it only shows up when there's a velocity, an acceleration, where something absorbs it. And right now the earth below me is absorbing the impact of me absorbing the arrows coming down. We're interacting right now in a vibration, in a force battle between me and the earth below me. It's feeling the pressure, and I'm feeling the pressure. Yeah, I don't think I need to get into the free fall argument. Yeah, this is probably enough of a video. Alright, till next time, such. And so forth. I have to do writing, and it's just, just so stalled in trying to explain this in written words, because, you have to be more careful. And I'm finding it frustrating. But whatever, it's my burden to bear. Blah, blah, blah. You want to contribute somewhere, somebody likes writing. Appreciate it. But I don't think there's anyone up to the task. Anyway, till next time. And such.